My name is Mark Hallett. It is a pleasure to be here on June 15th, 2015 at the International Congress of the Movement Disorder Society. And I have the pleasure of interviewing today Dr. Thomas Chase, who's had a very nice career in experimental therapeutics. And we're going to talk about his career and some of the activities that he's had over that period of time. What I'd like to do is just start out by getting a sense of how you got interested in medicine and neurology in the very first place.
Well, thank you, Mark, for, first of all, the nice introduction and the nice invitation to come and participate in this interview series. It's really an honor to be here. Also, it's a pleasure to get down and sit with you for an hour and talk about things. Although we've worked together for maybe 30 years, I think we published one or two papers together. We've hardly ever sat down for an hour, just you and I, and talked. So this will be fun.
Absolutely. So
the question is, how did I get started?
How did you get started?
I was born in a leafy community outside of New York City called Westfield, New Jersey, in 1932. My father was an industrial chemical salesman and commuted every day to New York City by train and then ferry. And I had a typical upbringing, I think, at the time. As a child, I had no interest at all in medicine. My family were business people and lawyers, no academicians, no doctors. I don't think the thought of being a physician ever entered my mind. So I didn't fix birds' wings, but I did fix radios and build transmitters and oscilloscopes and things like that. I was always interested in how things worked. And so I remember my first foray was disassembling my father's watch and with a hammer or a screwdriver or something and getting punished for that because, of course, it was destroyed. But I went on to actually learn how to repair broken radios, which fortunately involved mainly just replacing a burnt-out vacuum tube in those days, so it wasn't so difficult. How did I get into medicine? Well, I guess I should tell the story of my interest in engineering and electrical engineering in particular. So when it came time to go to college, I went to MIT because that was the best engineering school that I could think of at the time.
And they had vacuum tubes there. They knew what to do about
They
vacuum
knew what to do with vacuum tubes. And there was another consideration. I had a girlfriend then who was going to Wellesley, so it was a very convenient location to be in. At MIT, as a younger child, I used to go to the library and read various things. And one of the things I read about was how the brain functioned. And in those days, the books that I was reading described the brain as some sort of telephone switchboard with all these circuits and plugs. And I was so fascinated by this idea, I couldn't really disabuse myself of the notion of finding out whether it really worked that way. So at MIT, I hung around with people in the engineering department, electrical engineering department. They were interested in circuit theory. And there was one person who was particularly influential to me. His name was Norbert Wiener, and he worked on a discipline called cybernetics in those days. It was sort of feedback mechanisms. He was a very aloof man and probably didn't know me, but I would hang around him and listen to him from time to time. And actually, I got up my nerve several times to ask him questions. But his influence was important, and I wrote my thesis at MIT on feedback mechanisms in the human brain, not knowing a thing about the human brain, but knowing something about how engineering principles might be applied to the human brain.
Right, now at that time, if I remember right, he wasn't the only one who had this sort of notion about brains in computers. There were really lots of people at that
Yes,
point
that was
at
the
MIT.
That was the prevailing view. It didn't sound superficial in those days. But I must say that it lasted about 3 or 4 months of medical school before I realized that thinking of the brain in those terms was ridiculous, and that anyone who wanted to really study the brain had to go about it differently.
Right. Well, it's clear that you got interested in the brain that way, but you were still at MIT as an engineer. You just said that you got to medical school. How did you make that decision?
Well, I graduated from MIT and took my first job. It was with a sewing machine manufacturing company called Singer. They had 75,000 employees in those days. It was a very prosperous and well-managed company. And I was a management intern, and was very well treated, and had access to many of the executives in this company, and they showed me around and tried to train me to be a good sewing machine man. And I thought that this was interesting, but the longer I stayed with Singer, the more disillusioned I became. I was particularly assigned to one individual, one executive, the vice president for research and development. And during the year, I spent a lot of time with him, but by the end of the year, I was disillusioned because the major decision that he made during this period was whether a sewing machine should be painted green or brown. And I thought this was a fairly trivial decision for a man who was in charge of research for such a large corporation. Furthermore, the idea of a sewing machine is to stitch 2 pieces of fabric together with a thread. And the thread has to tie a knot, and the machine ties the knot for the thread. And in order to do that, it throws out a loop. And the way the loop is thrown out and twisted in the process is essential for the knot to be tied in a smooth way. Well, how did they design the camming surface to throw out the loop of thread to make a perfect knot? No one knew. It was the work of a tool maker given a block of steel, when he would file it down until it worked perfectly. But they had not the slightest idea how to tie a knot. And I thought, well, if you have a company that big and in operation that long, they should know what the hell they're doing, but they don't. They didn't have the slightest idea, nor did they really care. I actually spent some time trying to figure that problem out, but gave up in disgust because I couldn't make much progress.
But still, medicine was in the future, so how did you go from sewing machines to medical school?
All right, so I was a disillusioned management trainee at Singer, and the next thing that happened in my life was that the Army called. I had been in ROTC in college, and so the Signal Corps said, it's time for you to go to Korea. That was the war that had transpired in my time. And when I got to Korea, the war had just ended, but the effects of the war were everywhere. It was a very sad time. The people were poor, the land was damaged. The Army American Army was everywhere. My job was to maintain telephone communications between the various air bases in Korea. So it was interesting, except that it really reduced itself to putting up telephone poles between these airports and then stringing copper wire between the poles so that the communications could be maintained. And this turned out to be a little game because the copper wire that we put up was very valuable. So my troops during the day would climb up these poles, string their wire, and then at night the Koreans would come out and unstring the same wire. So we were doing the same thing back and forth for a long time. Nobody really particularly didn't bother people too much because we were trying to learn how to subsidize that economy. And this American subsidization made a huge impact eventually. But this was really the beginning of the subsidization process of donating copper wire to the people of Korea. And that's what I did. There was one other aspect to my job, which was a minor aspect, but actually was influential. And that was that I was the movie impresario for Korea in the Air Force. The Signal Corps one of their responsibilities was to entertain the troops with movies. And each week, a shipment of film, 16 millimeter film in cans, tin cans, would come over, and I would have to decide which Air Force base got which cans of film. So I really became very familiar with movies during that period. And amongst the film that was transported to us each week or month or whatever it was, were training films for doctors. And so I would show myself all the films just to select which ones went where, but also the medical films I watched with interest and with increasing interest. And I thought, gee, this is really fascinating. And the neurologic ones were particularly fascinating. Unfortunately, most of them were dealing with traumatic problems of battlefield injury, and so were not so relevant to the kinds of things that I did subsequently. But anyway, the idea of the brain, learning how things functioned, learning to fix things that were broken, the telephone switchboard concept, which later was going to be exploded because it didn't work, as applied to the human brain. All those things were things that made me think, I really want to go into medicine. And actually, I tested that concept when I came out of the Army. I worked as an orderly at a local hospital, and I was the only MIT-trained orderly in this hospital. And so I got to do very special things and also learn very special things, because orderlies in hospital are treated, in those days at least, as almost non-people. So everybody would talk in front of me, the doctors, the nurses, everyone. And so I picked up everything I heard, and pretty much soon I really understood how the hospital functioned, which was not always to the full benefit of the patients there. In any event, I got to do lots of procedures because the doctors came and went, and there was probably one intern for this 300-bed hospital, and who was overworked and undertrained. And so I would start IVs and put in catheters for men with big bladders, and I even helped with LPs. So I really got the hang of doing medical procedures very quickly, because I was good at it. I learned it quickly, and I could do it better than almost anybody else.
And so then you decided you would do it as a career.
Yes. While I was working there, I decided that I would upgrade my experience, and I went to Columbia P&S, and which was the local medical school, and I decided I would work in a laboratory to see what medical research was all about. And I, for reasons that I don't remember, I got hooked up with John Latimer, who turned out to be a very distinguished urologist, and one of his faculty members, Hans Zinzer, in the Department of Urology. And they were very good to me. John Latimer would take me on special rounds. His residents were sleepy. They were overworked and tired all the time. And during his rounds, one after another would be called off to do something else or virtually fall asleep. And so I was the last man standing in most of these rounds because I was fully awake and very, very interested in what was going on. Anyway, I did two things. One was to study oxalate stones, kidney stones. And so I got familiar with running a little stone clinic because, again, the residents were late coming, and I got there first in the morning, and I learned how to take a history and do all these things, and also collect my urine samples, which we worked on for the rest of the day, and got a feel for the pleasures of taking care of people who had problems. And I can tell you that renal stones really hurt, and when you get a renal stone, you come to the clinic because you sure don't want to have an experience with another stone. And the second thing I did was the person that I was working with worked with the population council, and people who suffered from infertility would come to this person's clinic, one of the clinics. And I said, oh, I think I can help with this infertility workup. I will measure how well sperm move. And I invented a little machine called the sperm machine. And it was actually a flying spot scanner, an oscilloscope that scanned across a test tube. We took a sperm sample, centrifuged it down mildly, and then watched the sperm swim up to the top again. And we measured how fast they did this. And I found out that there were 3 kinds of sperm. The good ones that did a search pattern and got up to the top very quickly. There were other sperm that also swam very quickly, but in the wrong direction. And then there were the guys that didn't move at all, or hardly at all, just sort of flipped around and didn't actually get anywhere. So I had a lot of fun with that sperm machine, and so much fun that I got invited to give my first lecture, a scientific lecture, in an international meeting in Canada. And I hadn't even gone to medical school, and they called me doctor, and I was very pleased. I didn't correct them.
Right, but somehow urology got into neurology. But you were still you were interested in the brain.
Yeah, I was interested in the brain, and I had John Latimer tried to recruit me into urology and all that, but I didn't want to do that. Anyway, I went to medical school. Medical school turned out to be rather easy after being an engineer, and I sort of slid through it. And I actually went to pre-medical school first, and because I had not taken any of the preparatory courses that you're supposed to take before you go to medical school. And I had a very nice time at Yale because they had what was called the Yale system, no exams and no pressure to do one thing or another. They said, you're a mature person, and I felt mature at that time and knew exactly what I wanted to do, which was to do research and find an organ that I really was interested in. And I thought initially, of course, that the brain would be it. But when I was disillusioned to find the brain did not have a switchboard operation, I said, gee, this is too tough for me, and I'm going to look for something else. And I wrote my thesis on aortic elasticity. And that was a very good lesson for me because I did that by myself without much help from anyone. And it didn't work out very well. And so I learned that research is complicated. You need help. You need to get a group together. You need to get various expertise to come together to actually complete a good project. And so even though the thesis was a lousy one as far as I was concerned, the experience was very important to me, and so I learned a lot from it and ended up in medical school saying I want to be a neurologist.
Was there anybody at that point who turned you in that direction for neurology? I mean, it sounds like you had a urologist who you were dealing with, but there must have been at least someone who was a model.
Well, I had 2 experiences. Yes, a good question. I'm struggling a little bit to think about what were major influences at that time. One comes to mind in that I started, well, the first thing I learned was as a pre-medical student, I had a very smart, very effective laboratory partner. Not really a partner, but he was in the next bench over. And one day I asked this guy, who was a little older than most of the other people, what did he do? And he said, I'm a neurologist. And I said, gee, where do you work? And I said, in a hospital north of here, P&S. And I said, gee, what do you do? And I had many interesting and stimulating conversations with him. He turned out to be important in my life for many ways, and that was Bud Rowland. And he was doing a chemistry course at that time because he wanted to do more research. So that was one influence. The other influence was that while I was working as a urology technician, I made rounds, and I told you about rounds with John Latimer, but I also made rounds in the Neurologic Institute. And I guess I did rounds maybe once a week with the residents. Mm-hmm. And I found that what neurologists do was very compelling, very interesting, and something that I really wanted to do.
So then you decided to go to a neurology residency, and you went to Boston, though.
Well, I was very lucky always to be at the right time in the right place. When I went to apply to medical schools, I think I applied to 6 or 7 schools, and I felt that my atypical background was going to harm me, and I would come in and say, you know, I don't know much about pre-medical things, but I'm an engineer. And I thought that they would scoff at me and kick me out. But quite the opposite. They got very interested. And I actually, one of the people I interviewed with at Columbia was Mel Yar, and he brought me to the dean of the school because he was so fascinated with some of the ideas I had about how the brain worked. Mm-hmm. And of course, nobody knew in those days. The research in the brain in the 50s was largely grind it up and find out what are the constituent chemicals. And I thought, well, gee, I could never learn about function in that way. And I scoffed at that. And this was my telephone switchboard days. But I think that those were the major influences in getting into neurology. So when I wanted to apply to neurology, I remember going to my chief at Yale, a little afraid to tell him that I wasn't going to continue internal medicine and go on to be a resident. And his name was Paul Beeson, also a wonderful doctor and a very strong influence to me about how doctors acted and how they took care of people. And I didn't really spend a lot of time with him. He was very busy. But every time that I had a very brief conversation, he was always very impressive. So I was a little afraid to go into his office and say that I was bowing out from the rest of his training program, that I wanted to go into neurology, and I was 4 years behind my peers and wanted to get started. And so I thought he would get mad and say that was the dumbest thing he'd ever seen. But no, he said, gee, I'm happy because I have too many applicants, actually, and you will make a slot for somebody, but you better find a job because there's not going to be any more job. I'm going to fill your job here. And so I knew that I had to quickly find a job while I was an intern. And so I started going around to neurology programs, and quickly I found out that I was a desirable candidate and pretty much had my pick. And so I was most impressed with Raymond Adams and made the choice to go there. Mm-hmm. And that wasn't a bad choice for me. I was just absolutely astonished by how many good people the Mass General had in those days.
So do you want to tell us a little bit about the residency and how it molded what you finally wound up doing?
Well, again, I had my own agenda, which was to learn how the brain worked. And so I was less interested in clinical phenomenology and much less interested in neuropathology, which was one of the focuses of that program. And so I would duck out of many of those responsibilities and spend time with various people who did things around Harvard. And Harvard was just filled with wonderful people, smart people working on the brain, and they were doing great things, and it was a very stimulating period for me. So what most people got out of a training program with Ray Adams was to be an academic neurologist and maybe a neuropathologist. I came away saying, I want to be a therapist. And I really didn't like the insulting behavior of some people who said, oh, you're a neurologist, that's diagnosis and adios, or whatever it was, you know.
Diagnose and adios.
Yes, and it was not, you know, people in neurology spent time thinking about where in the brain something went wrong and so forth, but didn't spend a lot of time in trying to take care of therapy. In fact, there weren't a lot of therapies there in those days. And so, again, just like with Paul Beeson, I was a little afraid to tell Ray Adams that I wasn't going to take his suggestion, his usual suggestion for all his residents was be a doc in the Boston area and be an assistant professor at Harvard or whatever it was, instructor and assistant professor, and come in and work at night in the lab. I thought, well, you can't do research at night. You've got to spend full time at that. So I thought that was terrible. But so I went in and said, you know, I really don't want to do pathology. I don't want to do the usual academic research. I think I want to be a therapist and learn how to treat neurologic disease. And about that time, one of the lecturers that came through the department was Seymour Ketty from NIH. And he had been working with Julie Axelrod and other people doing neurochemistry and transmitter pharmacology, and all of that just fit in perfectly. I said, that's the way to do it. Understand how nerve cells communicate, understand how you can manipulate that process with drugs, and you can probably modify symptoms. And so that's what I decided to do.
And so what year was that now that you started? So you
That
finished
was
your residency and you went right down to NIH?
1966.
1966.
It's lucky that I did go to NIH because I had been awarded a special fellowship, so I had money and I could go wherever I wanted to. That was a very popular mechanism in those days. Didn't have to do anything to get these fellowships. I think you just had to fill out a form or something like that. It was very easy. Anyway, I was impressed by a laboratory in Sweden that did DNA chemistry and was trying to understand the genetics, neurogenetics of human disease. And I thought I would go there. That sounded like a real adventure, and the laboratory was very highly praised in those days as being a leader in the field. And at the last minute, one of my classmates says, you should come down and see Seymour Ketty and Julie Axelrod because they really have the secret for making real advances. And I thought to myself, maybe I should do that before I make my final decision. Fortunately, I went down and I just clicked. It was, everything fell into place. This is what I want to do. These are the people I want to work with. And I forgot about going to Sweden. And I had a very good experience there, too.
Right, and that sort of began your career at NIH that went then for what, 35, 40 years, or how many years altogether? I lost count myself.
Yes, yes. I stayed there for 39 years. I had an upside-down career at NIH. I started out as a special fellow. After a couple of years, this will surprise people who are struggling to get tenure at NIH these days. One of the administrative officers came to me and says, we've just decided to make you a full-time government employee. And I said, not in your life. I'm not going to be a civil servant. Are you crazy? Being a civil servant somehow had a derogatory feel for me. And I said, I'm very happy here. I'm doing what I want to do, but I'm very happy with whatever the pay system was. I was being compensated adequately, and tenure didn't make much difference. I knew I could always find a job somewhere. So the idea of being an NIH employee was not attractive at all. And this lady was a rather formidable woman, and she was not used to having anybody say no, and I can still see her in front of me, her face dropping. She thought I would be so pleased by the offer. In those days, I guess there was some kind of tenuring process, but I was unaware of it totally. And until she came into my office and made this offer, I had never really thought about what next. And so, but after a while, I decided to join up and become a section chief or something like that. But after a few more years, the same thing happened. I got a call from Don Tower, and he asked me to come over to his office. I think I'd been in NIH 6 years at that point. And was just beginning, I just had gotten tenure and had become a section chief and had, I think, 2 people working for me. Don Tower called me over, and I thought I had done something wrong because he was another institute and he was going to criticize me for something, or I don't know what. It never occurred to me that it was to interview me for being his scientific director and the director of intramural program, But very quickly it became apparent, and I said yes within 10 seconds of the offer, saying, gee, I better not screw this one up. It's a good deal to jump up all
Right,
those
so
levels.
just clarify, you had been in NIMH, and then this was the offer to go to NINDS.
Yes,
and
another.
then the rest of your career was spent in NINDS.
Yes, yes.
Although the names kept changing, NINDS was not NINDS when you moved over. I guess it was NINCDS or
Something like that, yeah.
something like that.
Yeah.
So in terms of your career at NIH, or particularly, well, NIMH or NINDS, what are some of the highlights? What are the things that you're most proud of in terms of the things that you first identified, or the sort of contributions that you made while you were there?
Well, first of all, I had a wonderful time. I was exhilarated, couldn't stop working. I used to work late at night simply because I was so interested in what the results were. It was really very exciting. And I had a lucky experience in that the lab that I worked in, which was run by a man named Irv Copen, across the hall from Julie Axelrod, was doing psychiatric research, but looking at neurotransmitters in relation to psychiatric symptoms, and particularly affective disorders. And so all I had to do was do the same thing, except look at movement disorders or cognition. I was interested in cognition. But in order to do cognitive symptomatology in a rat, I couldn't figure that one out. And I didn't want to work with monkeys at that point. And so I said, movement disorders is much easier. And about that time, Carlson made the link between dopamine and Parkinson's, which was, I thought, a marvelous link. And he was very influential at that point. I said, oh, okay, that's what to do. I will simply take the technology and the approaches used in this laboratory for affective disorders and apply them to the basal ganglia and movement disorders. And that's easy. Anybody can do that. Actually, I had a machine that Irv started inventing that I worked with in my first year there. It was called the brain slice machine, sort of like my sperm machine. It was a machine where you sliced up the brain and put it into little bowls and then stimulated it and watched what happened to the neurotransmitters, which were labeled isotopically. And the machine unlocked a lot of secrets about transmitter pharmacology, and you could put drugs into the chambers and so forth. And it was so good that people used to kid me and say, you put a brain slice into this machine and out pops a paper, because we were publishing like once a month in Science and Nature and very good journals. So it was very interesting. But while I was doing that, I was also thinking about more complicated work. And I guess in the early days, there were, after that initial laboratory period was over, I was interested in getting onto the ward and trying to apply some of the technology and approaches that worked in the rat to humans. Mm-hmm. And we had isotopes, and we had spinal fluid, so that was the two things that I worked with. And I asked the NIH people if I could have some beds to do research on. And at that point, the neurology department had, this was NIMH, mental health, and so they had some extra beds that were not fully utilized, and so I got 2 of them and started my research. And one of the first things I got interested in was dystonia, because of one of my colleagues at NIH. And I just was trying levodopa on lots of things, including Parkinson's at that time, without much success because it was very emetic. And one of the things we tried it on was children with dystonia. And I stumbled across a pair of siblings that had dystonia which responded. One of the siblings, the boy, responded miraculously. He was completely bedridden without dopa, and when you gave him dopa, he could get up and catch a ball and run around. And so that was such a dramatic experience for me. I just could not imagine being such a powerful effect of a drug on a brain disease.
So let's go back to accomplishments at NIH. There's a lot of the work that you did there in relation particularly to Parkinson's disease therapy that have been quite influential. Which of the things are you most proud of in terms of the things that have been discovered in your group?
Thank you for asking the question in a very nice way. I always feel as though I'm falling short of what I should do and leave a problem too soon. But I guess one of the things that I got interested in when I stopped being an administrator at NIH was to find out why DOPA worked so well initially and then failed to work very well later, motor response complications. And so, first of all, we took on the presynaptic side and became aware of, I don't know whether we were the first, but certainly among the first people to understand that wearing off phenomena, the shortening of the duration of action of levodopa, reflected a diminishing number of dopamine terminals that could store the amine. And so as you went on, you had to give dopa more frequently because it didn't last as long. And then we began to turn to the postsynaptic side. And in those days, neurologists very glibly said, oh, motor response complications, dyskinesias, and these sudden fluctuations reflected supersensitivity of the postsynaptic dopamine receptor. And that always annoyed me because what does that mean? I mean, where does it get you? So I spent maybe 10 years trying to figure out what is happening postsynaptically when you pulse a system which is normally tonically active. I mean, we were very lucky, really, amongst the transmitter abnormalities that you can deal with in neurology, to have a disease where all you had to do was to maintain an environment with sufficient dopamine, and the dopamine neurons would fire off nicely. What we didn't understand initially was that the PK of levodopa was terrible for this situation. It had a half-life of a few hours, and so the levels were going up and down all the time. And the postsynaptic receptors were not used to that. That's not the way they operate. And so continuous stimulation was very important. And so I worked on the idea of continuous stimulation, trying to prove that it was important for a long time. And then even longer time, and still today, work on ways that we can achieve continuous postsynaptic dopamine receptor stimulation. It still has not been done really well. I worked on a dopamine patch, a reticotine patch, for a long time, 10 years, I guess. Actually, I was, in some ways, a discoverer of that patch. I don't know whether you have time for the story, but I was...
Sure, tell the story.
In Holland at a meeting, and somebody told me about Alan Horn, who was in Groningen, the north of Holland, had a wonderful group of dopamine agonists that had properties that might lend themselves to the treatment of Parkinson's disease. So after the meeting was over, I rented a car and drove up to the north of Holland on a rather stormy night, or a stormy day, I guess it was, and got to his lab, and he showed me his books, and he had 20 or 30 molecules. He was a medicinal chemist, and he showed me all these molecules. And the one molecule that leaped out was a molecule that was very lipid soluble. And I said, that's the way to do it. Give it transcutaneously, and you can always have it. So that started a series of research endeavors trying to get this drug licensed to an American company, and it started out with Nelson Laboratories in California, small companies. It went through the hands of 4 or 5 companies before it finally got into Schwartz and bigger pharma, and all the patches were unsuccessful. You had 2 problems. One, it didn't get through without a penetrator. The penetrators all caused local irritation. And so what I found out, one thing I found out was, first of all, Parkinson patients loved patches and they were very proud of them. And in the morning when I would make rounds with these patients, they would flip up their T-shirts and show me their patch. And so I said, all right, patches are okay. But as soon as I would peel back the patch, there would be the rash. And so, and we had that problem, I guess, for 10 years before it was pretty much solved. But other ways of getting continuous stimulation proved very difficult. So then I decided that I would look and see how periodic stimulation, pulsable stimulation, could re-regulate the postsynaptic neuron, the medium spiny neuron in striatum. And so we spent many years looking at the, well, I guess it's the question of synaptic integration. How does a nerve cell decide, based upon all these inputs, how to fire? And of course, part of the answer, a very complicated problem, part of the answer is that each receptor for different transmitters interacts with each other receptors and regulates its sensitivity to its own receptor through signaling mechanisms, PKC and PKA and CAM kinase 3 and all these enzymes which phosphorylate the segments of the receptor. And so working that problem out turned out to be very interesting. And one of the first applications was the NMDA receptor. And part of the NMDA receptors gets hyperregulated, rephosphorylated where it shouldn't be as a result of intermittent stimulation, which does not occur with continuous stimulation. And that you can correct that in part by blocking the receptor. And so that led us to amantadine. And I'm very proud of amantadine because that really is an example of something that you can start with a concept and then go ahead and try it out in a rat, and it worked. And then try it out in an MPTP monkey, and it worked. And then try it out in a patient, and it worked again. What I'm sad about is that it doesn't work all that well, and nothing has come along, to my knowledge, since then that is a lot better. So we still don't know how to downregulate an upregulated NMDA receptor, but at least some of the questions that we should be addressing are clearer than they were when I started.
Let me switch topics, a couple of other things I'd like to talk with you about. In terms of trainees, you've had a large number of trainees and many have been quite successful. Do you want to tell us a little bit about that?
Yes, yeah. Well, there are so many aspects of career in neurosciences research. The administrative part, the patient care part, the training of young people, they all fitted together beautifully at NIH. And NIH, as you know, is a magnificent venue to put all those pieces together because you can do pretty much what you want to do. Anyway, I was the recipient of many good students over the years, and I lost count after 100 or something like that. You probably trained twice as many by now, but I think that they have been my inspiration and the energy and the brains behind so much of what I was able to accomplish. So I can't be thankful enough for these wonderful people that came through our lab. When I started out, the Vietnam War was in progress, and the Yellow Berets came through. And in order to avoid the draft, they came to NIH, and a lot of them were terribly smart, well-motivated people, and you just wanted them to work with you. And I had so many good people starting out, and that continued after, because I got the reputation of being a decent place to train, and so over the years we continued to get people from all over the world, as well as the United States, to come and spend a few years with us. And that was a very special privilege, which I sort of took for granted while I was at NIH. But I found that it really was very important to my own research that I had so many smart people around me, not only other colleagues, but also students.
And one last question. So you finally retired from NIH, but you haven't given up. You're still chugging on. You're still doing interesting things. Do you want to give one or two comments about your continuing work and your continuing interest in solving problems for patients?
One of the frustrations of working at NIH is you can't follow a therapeutic idea from one end to the other, right to the patient. After phase 2, it's hard to run a phase 3 trial at NIH, and it really has to go into the hands of big pharma. So I never could really control how some of our drugs and therapeutic ideas were followed up, and in some cases I thought they were messed up by big pharma. The advantages of what I was trying to do were never quite realized. And over the years at NIH, I had gotten the usual invitations to look at other jobs, including at big pharma, and had always resisted because I really enjoyed what I was doing and didn't want to change. Finally, I had been working with a group of venture capitalists, and they came by and said to me, "We have an offer that you can't refuse." And I said, "Well, I've heard this before, but go ahead." And they did have an offer. Almost everything that I asked for, I said, "It's yours." And so I decided after 39 years that I would hang up my, whatever you hang up in a neurologist's office, and proceed into the world of entrepreneurial medicine. And so far, I have started and become the founding CEO of 3 companies. The first was dealt with a product for apathy, and I'm still sad that we lost it to another company because apathy remains a neurologic disease, I think, which is totally untreated. There's no drug for it. In fact, it hardly appears in textbooks, but apathy is a very important symptom, and people who are apathetic need to be treated and should be treated just like people with depression. That work still has to go forward. Currently, my biggest work is in Alzheimer's, where I'm working on a way to improve on current therapy, which we think will transform the field. I say that with all due modesty. We break our phase 2 blind in about 4 or 5 months, and we will find out how good the idea is. We're also trying it in Parkinson's dementia, and have just applied for a grant to support that research. And then I have another company and another product for Parkinson's disease, a therapeutic product, which we think is going to be very interesting. And so I've really enjoyed the idea that if you're going to have a second career, which I advocate, think and encourage people to do, working in industry is not all that bad. I had always looked at big pharma and pharma generally as commercial and the dark side and things that you wanted to avoid at all costs. But I'm having a good time and feel as though I have good control over finding the resources to solve a medical problem, and then carrying that problem solving forward to the very end, the commercialization and the marketing of a product that will make people better.
Right. So it really, I mean, what you were just saying there is really the story of your whole career. I mean, starting with very basic science, working on translational problems of various kinds, and finally now dealing with these are the products, we want to get them to the patients in the end. So it's it's a nice story anyway.
Well, thank you very much. I've certainly enjoyed my own career, and people sometimes ask me, would I do it differently? And I certainly wouldn't. Although my career has been upside down and backwards, and I've certainly gone in a lot of blind alleys, nevertheless, it's been very satisfying for me to be a participant. And I think that we're doing currently exactly what I want to be doing, and I hope to continue for a while.
Tom, thank you very much. It's been a pleasure talking with you, and I think that what you've said may well be inspirational to a number of other folks.
Thank you very much, Mark.
Thanks a lot.